Voltage refers to the electrical potential difference between 2 points. Phase refers to the timing and waveform of electrical current or voltage. Three-phase power is a type of alternating current power that has three conductors with three voltage signals that are 120 degrees out of phase with each other. Low-voltage three-phase power is typically in the range of 208 to 240 volts line to line. High-voltage three-phase power is used for industrial applications and is typically 480 to 600 volts line to line. In your situation, you have 120 volts, 120 volts, and 240 volts available. 120 volts and 240 volts are not standard three-phase voltages. You need to determine if you have three-phase power available or if it needs to be run to the conveyor. To determine if you have three-phase power, firstly, use a voltage tester to measure the voltage between each pair of terminals. Secondly, you should have the following voltage readings: 120 volts between terminals A and B, 120 volts between terminals B and C, 240 volts between terminals A and C. If you have three-phase power, you can connect the Leeson motor directly to the three-phase power. The motor's nameplate will indicate the correct voltage and phase configuration. If you do not have three-phase power, you will need to run a new three-phase power supply to the conveyor. Contact a qualified electrician to perform this task safely and ensure proper wiring practices. It's important to note that running a motor on the wrong voltage or phase can damage the motor and void the warranty. It's always best to consult with a qualified electrician to verify the correct power supply for your equipment. Three-phase power is a common method of electrical power transmission. It is more efficient than single-phase power, which is typically used in homes and small businesses. Understanding three-phase power involves several key concepts, including voltage, phase, and the relationships between them. Voltage, as mentioned earlier, is the electrical potential difference between 2 points. It's the driving force that pushes electrons through a circuit. In the context of three-phase power, we often talk about line-to-line voltage, which is the voltage measured between any two of the three conductors. We also talk about line-to-neutral voltage, which is the voltage measured from one of the three conductors to a neutral conductor if present. Phase refers to the timing and waveform of the electrical current or voltage. In a single-phase system, the voltage and current oscillate together. However, in a three-phase system, the three voltage signals are offset by 120 degrees. This offset is what makes three-phase power more efficient. Because the power delivered is more constant over time, rather than pulsing as it does in a single-phase circuit, the 120-degree phase difference between the three voltage signals in a three-phase system is crucial for its operation. This phase difference ensures that the power delivered is relatively constant over time, reducing the need for large capacitors to smooth out the power flow. The voltage between any two phases in a three-phase system is higher than the voltage between any phase in neutral. This is because the phase voltage is advectorially. The most common three-phase voltage configurations are 208 volts, 240 volts, 480 volts, and 600 volts. The specific voltage used depends on the application and the local electrical code. When working with three-phase power, it's essential to identify the voltage levels correctly. Using a multimeter, you can measure the voltage between each pair of terminals and between each terminal and neutral. If the voltages are not what you expect, there may be a problem with the power supply. If you're not familiar with three-phase power, it's always best to consult with a qualified electrician. They can help you identify the voltage levels, ensure that the wiring is correct, and troubleshoot any problems. Connecting a motor to the wrong voltage or phase can cause serious damage. The motor may overheat, burn out, or even explode. It's also important to ensure that the motor is properly grounded. Grounding provides a path for fault current to flow, which helps to protect people and equipment from electrical shock. When working with three-phase power, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on live circuits unless you are qualified to do so. If you are not sure how to do something, ask for help from a qualified electrician. In your specific situation, you mentioned having 120 volts, 120 volts, and 240 volts available. This is not a standard three-phase voltage configuration. In a typical 208-volt three-phase system, you would have approximately 120 volts from each phase to neutral and 208 volts between any two phases. Similarly, in a 240-volt three-phase system, you would have approximately 120 volts from each phase to neutral and 240 volts between any two phases. Because you have 120 volts, 120 volts, and 240 volts, it's likely that you don't have a standard three-phase power supply. You may have a single-phase 120/240 volt supply, which is commonly used in homes and small businesses. If you need three-phase power for your conveyor motor, you will need to have a qualified electrician install a three-phase power supply. This may involve running new wires from the electrical panel to the conveyor location. It's also important to ensure that the electrical panel has sufficient capacity to handle the additional load of the motor. Before connecting the motor, be sure to check the motor's nameplate. The nameplate will indicate the voltage and phase requirements of the motor. If the motor is designed for 208 volts three-phase, you will need to connect it to a 208-volt three-phase power supply. If the motor is designed for 240 volts three-phase, you will need to connect it to a 240-volt three-phase power supply. In some cases, motors can be wired for multiple voltages. For example, a motor may be able to be wired for either 208 volts or 240 volts. The motor's nameplate will indicate how to wire the motor for each voltage. If you are not sure how to wire the motor, consult with a qualified electrician. Once you have connected the motor to the correct power supply, you can then connect the AC control to slow down the speed of the conveyor. The AC control will allow you to adjust the voltage and frequency of the power supply to the motor, which will in turn control the speed of the conveyor. When selecting an AC control, be sure to choose one that is compatible with the motor's voltage and current requirements. The AC control should also be rated for the environment in which it will be used. For example, if the conveyor is located in a wet or dusty environment, you will need to choose an AC control that is rated for those conditions. When installing the AC control, follow the manufacturer's instructions carefully. Be sure to disconnect the power before working on any electrical equipment. If you are not comfortable working with electrical equipment, consult with a qualified electrician. Once the AC control is installed, you can then test the conveyor. Start by setting the AC control to its lowest setting. Then, gradually increase the speed of the conveyor until it is running at the desired speed. Be sure to monitor the motor's temperature to ensure that it is not overheating. If the motor starts to overheat, reduce the speed of the conveyor or turn it off completely. By following these steps, you can safely and effectively connect a conveyor motor to a three-phase power supply and use an AC control to slow down the speed of the conveyor. Remember to always consult with a qualified electrician if you have any questions or concerns. Three-phase power systems are used extensively in industrial and commercial settings due to their efficiency and ability to deliver high power levels. Unlike single-phase power, which consists of a single alternating current voltage, three-phase power utilizes three alternating current voltages that are offset by 120 electrical degrees. This configuration results in a smoother and more consistent power delivery, reducing the need for large capacitors to smooth out voltage fluctuations. Identifying a three-phase power system requires careful voltage measurements between the various conductors. In a typical three-phase system, there are three hot wires, each carrying an alternating current voltage, and a neutral wire, which serves as the return path for current. The voltage between any two of the hot wires is known as the line-to-line voltage, while the voltage between any hot wire and the neutral wire is known as the line-to-neutral voltage. The line-to-line voltage is typically higher than the line-to-neutral voltage by a factor of the square root of 3, which is approximately 1.732. Common three-phase voltage configurations include 208 volts, 240 volts, 480 volts, and 600 volts. The 208-volt system is often found in commercial buildings, while the 480-volt and 600-volt systems are more common in industrial facilities. To determine whether a power system is three-phase, it is necessary to measure the voltage between each pair of hot wires and between each hot wire and the neutral wire. If the voltages are consistent with a three-phase configuration, then the system is likely three-phase. However, if the voltages are inconsistent, then the system may be single-phase or some other configuration. Connecting a motor to the wrong voltage or phase can cause serious damage to the motor. If a motor is connected to a voltage that is too high, it can overheat and burn out. If a motor is connected to the wrong phase, it can run backward or not run at all. Therefore, it is essential to verify the voltage and phase requirements of the motor before connecting it to a power system. The motor's nameplate typically provides information on the voltage, phase, and current requirements of the motor. The nameplate may also provide information on the wiring configuration for different voltage levels. If the motor is capable of operating at multiple voltage levels, it may be necessary to reconfigure the wiring connections to match the voltage of the power system. An AC control, also known as a variable frequency drive or VFD, is a device that is used to control the speed of an AC motor. The AC control works by varying the frequency and voltage of the power supplied to the motor. By reducing the frequency and voltage, the speed of the motor can be reduced. AC controls are commonly used in applications where it is necessary to adjust the speed of a motor, such as conveyors, pumps, and fans. When selecting an AC control, it is important to choose one that is compatible with the motor's voltage, current, and horsepower ratings. The AC control should also be rated for the environment in which it will be used. For example, if the AC control is to be installed in a dusty or wet environment, it should be rated for those conditions. Installing an AC control requires careful attention to wiring and safety precautions. The power to the motor must be disconnected before any wiring connections are made. The AC control should be grounded properly to prevent electrical shock. The wiring connections should be made in accordance with the manufacturer's instructions and all applicable electrical codes. After the AC control is installed, it is necessary to program it to operate the motor properly. The programming typically involves setting parameters such as the motor's voltage, current, horsepower, and speed range. The programming may also involve setting parameters to protect the motor from overloads, overvoltage, and undervoltage conditions. Three-phase power is used in many industrial and commercial applications because of its efficiency and ability to deliver high power. However, it is important to understand the basics of three-phase power and to follow safe work practices when working with three-phase electrical systems. If you are not familiar with three-phase power, it is always best to consult with a qualified electrician. It is also critical to differentiate between different types of three-phase systems. Delta and Y configurations are the two most common. In a delta configuration, the three phases are connected in a closed loop, forming a triangle. There is no neutral connection in a delta system. In a Y configuration, the three phases are connected to a common neutral point, forming a Y shape. Y systems are more common than delta systems because they provide a neutral connection, which is useful for supplying single-phase loads. The voltage between any two phases in a delta system is the same as the phase voltage. However, the voltage between any phase and neutral in a Y system is equal to the phase voltage divided by the square root of 3. When working with three-phase power, it is important to understand the differences between delta and Y systems and to use the correct voltage measurements for each type of system. It is also important to be aware of the potential hazards of working with three-phase power. Three-phase power can deliver high levels of current, which can cause serious electrical shock or burns. Therefore, it is essential to follow safe work practices and to use appropriate personal protective equipment when working with three-phase electrical systems. Always de-energize equipment before working on it. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not sure how to do something, ask for help from a qualified electrician. When installing a motor, be sure to use the correct size and type of wiring. The wiring should be rated for the voltage, current, and temperature of the motor. The wiring should also be installed in accordance with all applicable electrical codes. When connecting the motor, be sure to follow the wiring diagram provided by the motor manufacturer. The wiring diagram will show how to connect the motor to the power supply and to any control devices. Be sure to ground the motor properly to prevent electrical shock. Grounding provides a path for fault current to flow, which helps to protect people and equipment from electrical shock. After the motor is installed, be sure to test it to ensure that it is operating properly. Check the motor's voltage, current, and speed to ensure that they are within the specified limits. Also, check the motor's temperature to ensure that it is not overheating. If the motor is not operating properly, consult with a qualified electrician. Remember, safety is always the top priority when working with electrical systems. Following safe work practices and using appropriate personal protective equipment can help to prevent accidents and injuries. Three-phase power offers advantages like higher efficiency, smoother power delivery, and greater power capacity compared to single-phase systems. Understanding the basics of three-phase power, including voltage, phase, and system configurations, is essential for working safely and effectively with these systems. Always consult with a qualified electrician when dealing with three-phase power, especially if you are unfamiliar with the system or its components. By following safe work practices and seeking professional assistance when needed, you can ensure the safe and reliable operation of three-phase power systems. The motor's nameplate is a critical resource. It contains essential information about the motor's electrical characteristics, including voltage, current, frequency, horsepower, and speed. Always refer to the nameplate before connecting the motor to a power supply or control device. The nameplate will also provide information on the motor's wiring configuration, including how to connect the motor for different voltage levels. The National Electrical Code (NEC) provides comprehensive guidelines for the safe installation and operation of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and motor control. It is essential to comply with the NEC when working with electrical systems to ensure safety and prevent electrical hazard. Article 430 of the NEC covers motors, motor circuits, and motor controllers. This article provides detailed requirements for the installation and protection of motors, including overcurrent protection, overload protection, and short-circuit protection. Table 430.250 of the NEC provides full load current values for three-phase AC motors. These values are used to determine the appropriate size of conductors, overcurrent protection devices, and motor controllers. Always consult the NEC and other applicable electrical codes and standards when working with electrical systems. These codes and standards provide essential guidance for safe and reliable electrical installations. When dealing with motors and motor control, it is crucial to understand the different types of motor starters and controllers. Motor starters are used to start and stop motors, while motor controllers provide additional features such as speed control, overload protection, and reversing. Common types of motor starters include across-the-line starters, reduced voltage starters, and solid-state starters. Across-the-line starters apply full voltage to the motor at startup, while reduced voltage starters use various methods to reduce the voltage applied to the motor during startup. Solid-state starters use electronic components to control the voltage and current applied to the motor. Motor controllers can be manual or automatic. Manual motor controllers are operated by hand, while automatic motor controllers use sensors and control circuits to automatically start, stop, and control motors. Variable frequency drives, VFDs, are a type of motor controller that is used to control the speed of AC motors. VFD work by varying the frequency and voltage of the power supplied to the motor. This allows for precise control of the motor's speed and torque. VFD are commonly used in applications where it is necessary to adjust the speed of a motor, such as conveyors, pumps, and fans. When selecting a motor starter or controller, it is important to consider the motor's voltage, current, horsepower, and application requirements. The motor starter or controller should be sized appropriately for the motor and should provide adequate protection against overloads, short circuits, and other electrical faults. It is also important to consider the environmental conditions in which the motor starter or controller will be used. If the motor starter or controller will be used in a dusty, wet, or corrosive environment, it should be rated for those conditions. Always follow the manufacturer's instructions when installing and operating motor starters and controllers. Also, be sure to comply with all applicable electrical codes and standards. When troubleshooting motor control circuits, it is essential to have a good understanding of electrical circuits and motor control principles. Use a multimeter or other test equipment to check voltages, currents, and continuity. Also, check for any loose connections, damaged wires, or faulty components. If you are not familiar with electrical troubleshooting, consult with a qualified electrician. Electrical safety is paramount when working with motors and motor control circuits. Always de-energize equipment before working on it. Use insulated tools and wear appropriate personal protective equipment. If you are not sure how to do something, ask for help from a qualified electrician. Running a motor on the wrong voltage can lead to several adverse consequences. Firstly, the motor's performance will be significantly affected. If the voltage is too low, the motor may not be able to produce its rated torque, resulting in reduced speed and power output. This can cause the driven equipment, such as a conveyor, to operate inefficiently or even stall. Secondly, operating a motor on the wrong voltage can damage the motor itself. Overvoltage can lead to overheating, which can degrade the insulation and shorten the motor's lifespan. Undervoltage, on the other hand, can cause the motor to draw excessive current, leading to overheating and potential winding failure. Thirdly, using the wrong voltage can create safety hazards. Overheated motors can pose a fire risk, and insulation breakdown can lead to electrical shock hazards. It is crucial to ensure that the motor is connected to the correct voltage supply to prevent these issues. The motor's nameplate provides valuable information about its voltage requirements. The nameplate typically lists the rated voltage and the acceptable voltage range for the motor. It is important to verify that the available voltage supply falls within this range. If the voltage is outside the acceptable range, a voltage correction device, such as a transformer, may be needed to adjust the voltage to the appropriate level. Connecting a three-phase motor to a single-phase power supply is generally not recommended and can cause damage to the motor. Three-phase motors are designed to operate with three separate phases of alternating current, each offset by 120 degrees. When connected to a single-phase supply, the motor will experience unbalanced currents and voltages, leading to overheating and reduced performance. In some cases, it may be possible to operate a small three-phase motor on a single-phase supply using a special device called a rotary phase converter or a static phase converter. These devices create a simulated three-phase power supply from a single-phase source. However, phase converters are typically expensive and may not be suitable for all applications. It is always best to use the correct three-phase power supply for a three-phase motor to ensure optimal performance and longevity. If a three-phase supply is not available, it may be necessary to install one. This may involve running new wiring from the electrical panel to the motor location and installing a three-phase circuit breaker. A qualified electrician should perform this work to ensure that it is done safely and in accordance with electrical codes. Motor protection devices are essential for preventing damage to motors from overloads, short circuits, and other electrical faults. Overload relays are designed to protect motors from overheating due to excessive current draw. They typically consist of a thermal element that senses the motor's temperature and trips a circuit breaker or contactor if the temperature exceeds a predetermined limit. Short circuit protection devices, such as fuses and circuit breakers, are designed to protect motors from damage due to short circuits. They quickly interrupt the flow of current in the event of a short circuit, preventing the motor from overheating and potentially causing a fire. Ground fault protection devices are designed to protect motors from ground faults. A ground fault occurs when current flows from a motor winding to ground, such as the motor's frame or enclosure. Ground fault protection devices detect this current and trip a circuit breaker or contactor, preventing electrical shock hazards. It is important to select the appropriate motor protection devices for the motor's voltage, current, and application requirements. The protection devices should be sized properly to provide adequate protection without causing nuisance tripping. Also, be sure to test the protection devices periodically to ensure that they are functioning properly. Regular maintenance is essential for ensuring the reliable operation of motors. Motors should be inspected periodically for signs of wear and tear, such as cracked insulation, loose connections, and worn bearings. The motor's windings should be tested for insulation resistance using a megometer. The bearings should be lubricated regularly to prevent friction and wear. The motor's cooling system should be cleaned to remove any dirt or debris that could restrict airflow. Also, be sure to check the motor's mounting bolts to ensure that they are tight. Loose mounting bolts can cause vibration and noise, which can damage the motor over time. If any problems are detected during maintenance, they should be corrected promptly to prevent further damage. In addition to regular maintenance, it is also important to keep the motor clean and dry. Dirt and moisture can damage the motor's insulation and lead to electrical faults. The motor should be wiped down regularly to remove any dirt or debris. Also, be sure to protect the motor from moisture by installing it in a dry location or by using a waterproof enclosure. By following a regular maintenance schedule and keeping the motor clean and dry, you can extend its lifespan and ensure its reliable operation.